Welcome to today's DeepSense Discovery session. We are talking about choosing the right algorithm. So we are joined by Geetika, who is our Algorithm Software Specialist at Dalhousie. And we're super excited to talk about how do you choose the algorithm for the data you have or the problem you're trying to solve. So without further ado, I'm going to stop sharing. I'm going to pass over controls, and we are all going to learn just a tiny bit more about how do you choose algorithms.
Okay, thank you, Jennifer. I'm going to share my screen. Okay, so good afternoon, everyone. I hope the screen is visible to all of you. So, what happened? So good afternoon, everyone. So today I will talk on choosing the right algorithm for the AI projects. So myself, Geetika Bhatia, I am as an algorithm and software specialist with DeepSense. So first of all, we should know why it is important to choose the right algorithm for the problems. So we have a variety of algorithms in the machine learning, but it is very important to choose the right algorithm. The first of all, we need to save the time. So if we have a right algorithm in our hand, it will save our time. So, and second point is the accuracy. Again, with the right algorithms, we can improve the accuracy, or the right algorithm will give the good accuracy for our projects. So we need to there are two concerns for the project. One is the time and another one is the accuracy. So we need to concentrate on these 2 points. So that's why we need a right algorithm for the problem. So before going forward, I would like to introduce myself. I'm working as an algorithm and software specialist with DeepSense. So I did my master's in computer science with my thesis focused on ad hoc networks. I've submitted my PhD dissertation, and my thesis topic is modeling the anomalous behavior of user in social network. Basically, it is related to social network analysis, and I use the Twitter data for solving my problem, and in which, because my problem is classification problem, so I use the machine learning classifier in Python. I has been in with education sector for the last 15 years with a variety of roles such as assistant professor, project guide, and supervisor. And also I worked as a data scientist where I got a chance to explore the various deep learning algorithms. Now my area of specialization in terms of programming languages. So various programming languages, I'm expertise in Python, Java, C, C++, and regarding the AI frameworks, I'm very much familiar with Keras, PyTorch, TensorFlow. Regarding BI tools, familiar with Tableau. And if I talk about the database, I'm very much expertise in MySQL and Postgres. So this is a very good combination for doing the data science projects. So first of all, we should know what exactly is the relation between AI, ML, and DL. So AI is the artificial intelligence, ML is machine learning, and DL is deep learning. So as we can see from this picture, it will give us a very clear connection between the AI, ML, and deep learning. So AI here is the broader area, and machine learning is a part of that AI, and deep learning is a part of machine learning. So from this figure, it is clear that deep learning is the subset of machine learning, and machine learning is a part of the AI. So what exactly is AI? So AI, it refers to the simulation of human intelligence in machines. So what we put in the, using the artificial intelligence, we are simulating the human intelligence in the machine so that the machine will work as the human. And machine learning is basically are the applications or the way to simulate the human intelligence in the machine with the help of the various machine learning algorithms. So what machine learning is doing? Machine learning, it is having the capability to learn the models with the data. So whatever the data we have, we use that data to train the models and to learn the models, to learn the machine. And deep learning, it is a subset of machine learning where the artificial neural network plays a role, and these artificial neural networks are inspired by the human brain. So these neural networks, it works with same as that of the similar to the human brain. In the human brain, we have a neuron. So similarly, in the artificial neural network, there are neurons which will work same as the human brain. So before going forward, so there is some confusion between algorithm and model. So what exactly is the algorithm and what is the model? What is the difference between that? So algorithm is basically the set of steps or the procedure which we follow to solve the problem. And model, it is the overall set with the input, algorithms, and the output. If you see in this diagram, so the ML algorithms, it is taking the input and giving some output. If we talk about some machine learning projects or the deep learning projects, in this, the ML algorithms or the deep learning algorithms, they are taking the input in the form of the data set and provide us the output in the form of the classification and prediction. So this entire combination of the input algorithms and the output, it is a model. So the important slide is how to choose the algorithm. So what are the various ways of choosing the best algorithms? So initially you should know what kind of problem you're going to solve, whether it is related to classification or it is related to regression. So I'm going to cover what exactly the difference between classification and regression in the next slides. And other factors which we should concentrate on the data set, what kind of data set we have, because the data set, it is the main portion of the of our problem, which is the main input of our project. So we should concentrate on the data set. What is the size of the data set, whether it is a high dimensional or not, is there missing values or not, outliers are there or not. And other factor is the training time. So what kind of training time we need? So obviously for doing the projects, we need the training time, it should be less. So how can we improve the training time? And the accuracy, so the accuracy is also one of the important factor for choosing the right algorithm. How can we improve the accuracy? So whether our algorithm is having the capability of doing all these things, whether the algorithm is having the capability of improving the algorithm, whether the our algorithm is having a capability of decreasing the training time. So we need to think about that and choose the algorithm accordingly. So next is the type of problem, what kind of problem we have. So classification problem is when the output which we are going to predict, it is of the class type or the categorical data. For example, categorical data means either yes or no. If we are talking about, suppose, a classification of images, whether that image it is of a cat or dog. So there is a no particular value, but there is a class. So this is the classification data. So algorithms, basically the most commonly used algorithms for the classification are decision tree, support vector machine, k nearest neighbor, random forest, CNN, and RNN. And if we talk about the regression, in the target variable, we have a continuous data. Continuous data means when we have some numerical value, that is the continuous data. For example, when we are going to predict some value like a temperature, so that is the number. So that is called the regression problem. And the algorithms for the regression are linear regression, polynomial regression, lasso regression, elastic net, decision tree regressor, support vector machine regressor, KNN regressor, random forest, CNN, RNN. So there are various type of the regression models we have. So if we see this example, so the difference between the classification and regression will be more clear from this example. So this is a weather example. So if we talk about a kind of weather, whether it is a good or bad, so this is the classification problem. And if we are going to suppose predict some value for the temperature, pressure, or humidity, or wind speed, so these all are the regression problem where we find some value. The next example is, this is a very simple example. Suppose we have a student profile and we just want to predict whether he is pass or fail. So this is a class. So this is the classification problem. And if we are going to find some percentage or some value, suppose average marks or total marks, so that one is the regression problem. So now I hope so the difference between the regression and classification, it is clear. So before going forward, so first of all, you should select what kind of problem. You should identify what kind of problem you're going to do, whether it is a classification or regression problem. So in that way, you can classify the variety of algorithms in two parts of what are the classification algorithms or what are the various regression algorithms. Now, out of those classification or regression algorithms, which algorithms you need to choose. So we can decide on the basis of this table. So this is the table for the machine learning algorithms for the classification. So we can see the various, some common algorithms for the machine learning: the decision tree, SVM, KNN, naive Bayes, random forest. And the factors on which we can decide those algorithms are the size of data set, dimensionality, whether the data has noise, outliers, scale, whether the data need a feature scaling, easy to implement or not, or the training speed. So if we talk about the decision tree, it is suitable for both kind of data set, whether the data set is small or large. But it will not give a very good performance on the very large data set, because this decision tree, it is in the form of the tree. When the tree become large, the performance will become slow. So similarly, it can handle the multiple dimensions, but it will not be affected by any kind of outliers. Why? Because again, the decision tree, it is in the form of the tree structure. If we have the outliers or the noise, only a part of the tree will be affected, not the entire tree will be affected by that. So it is very easy to implement, but the training period is again very large because of the tree structure. Next is SVM. SVM is not very suitable for the large data set, but it is very much suitable for the high dimensions. It cannot handle the noise and the outliers. Why? Because the SVM, it is having the hyperplane. And if we have the outliers or the noise, the hyperplane will change accordingly. It needs a feature scaling, very easy to implement, and training period is very small. Next is KNN. Again, it is not very much suitable for the large data set. It is not suitable for the high dimensions. It is very sensitive to noise, sensitive to outliers. Why? Because again, the KNN, it depends upon the neighbors. If we have the outliers or the noise in the data, the result, the performance will be affected. Easy to implement, training period is less. If we talk about the naive Bayes, it is suitable for both the data sets. It is suitable for the high dimensions. It cannot handle the noise effectively, very sensitive to outliers. Easy to implement, training time is small because it needs less data to train. If we talk about the random forest, it is also a tree type structure. It is again suitable for both small data set as well as the large data set. It is suitable for the high dimensions. It can handle the noise, or it is robust to the outliers again, because it is the tree structure, so it can handle the outliers again, because if there is outliers or noise, only a part of that random forest tree will be affected, not the entire random forest. So it is very easy to implement, but the training period is large. So here we talk about the suitability of the algorithms. So suitability means, it doesn't mean you can't use these algorithms for the problem, but it will not give a very good performance. The accuracy will be less. So that's why we recommend you to choose first the algorithm, which algorithm is suitable according to your data set. If your data set is small or large, what kind of algorithm will work on it? If your that data set is having the high dimensionality, which data set will work with that? What kind of training speed it will give with what kind of algorithm, whether it is easy to implement or not. So based upon these factors, you can decide which algorithm to choose for the classification problems. So there are some models or the algorithms for the regression problems. So there is a linear regression, which you can use for the linear models. Polynomial regression, if you have a non-linear model, then you can use a polynomial regression. Then support vector regressor, decision tree regressor, random forest regressor. It can be used for both the linear and non-linear problems. So then we come to the deep learning algorithms. So in the deep learning algorithms, there are two common algorithms. One is the RNN and another is the CNN. So recurrent neural network, it is used for the recurrent problems. Recurrent problems means when the value which you are going to predict on the previous sequence of the input. So that is the recurrent. In that cases, we will use the recurrent neural network. For example, if you are going to find the predict the weather, so the based upon the previous, suppose 30 days weather or 1 year year of weather data, so that is the recurrent problem. Convolutional neural network is basically used for the in the case of the image classification. So, and we also have some pre-trained neural networks, which are mask RCNN, AlexNet, ResNet, VGG16, ExceptionNet, InceptionNet, YOLO. So these are the pre-trained neural networks. This is also called the transfer learning. So basically, these models are already made for one task, and you can reuse these models for some another task as a starting point. So it will save your time. So suppose if you want to go for the image classification, you can pick ResNet or VGG for that. So it will save the time. So because we already have the algorithms in hand, you don't need to build the entire model for the CNN. So here we have a difference between the machine learning and deep learning algorithms. So what kind of data set you have? You can use or you can apply both machine learning as well as deep learning algorithms, but based upon some factors. So here, if your data set is small, the machine learning algorithms can work very well with the small data set. But the deep learning algorithms, it needs a very large data set for giving the good performance. If we talk about the feature extraction, in the machine learning algorithms, we need to extract the features manually. We need to give the features. Like if you are going to classify the image, you need to give the features of the image like the eyes, whiskers, tail. We need to give that. But in the case of the deep learning algorithms, if we talk about the CNN, so the different layers in the CNN, it will automatically extract the features. Like it will first predict the edges, lines, then a complete picture. From the low level images to the high level picture, it will automatically extract and then classify the images. Then we talk about the training speed, because the machine learning algorithm, the training speed is very fast, and the deep learning algorithm, because these algorithms are very much complex and computation is high, so training speed is very slow. If we talk about the accuracy, the machine learning algorithms accuracy is lower than the deep learning algorithms. Why? Because the deep learning algorithms need a very large data set for giving the good performance. So when a model is having a very large data set, obviously it will give a good accuracy. Hardware dependency, the machine learning models can work well with the CPU, but the deep learning models sometimes require a GPU for the fast training. Hyperparameter tuning. The machine learning algorithms has a limited tuning capabilities. For example, if we talk about the SVM, you can only change the kernels. If we talk about the random forest, you can change the number of trees. But the deep learning algorithm, there is a variety of the hyper tuning parameters, like so you can play with the activation function, you can play with the learning rate, you can change the batch size, optimize the activation function, you can change the number of hidden layers, you can change the number of neurons in those hidden layers. Here you can play with the variety of parameters. So here we think, like if we see this table, it is clear that the accuracy, the deep learning algorithms are giving a very good accuracy. But if we get a training speed also high with this algorithm, then it would be really a great offer. So here a DeepSense plays a very good role in speeding up the algorithm. So here the DeepSense, it provide us the high performance computing platform, which comprises of a variety of compute nodes, and those compute nodes are made up of the GPU, consist of the GPU nodes, which help in training the model very faster. Training the model very faster means you can use those models or for the real-time applications also, because it speed up the model. So here, how the GPU helps in speed up the model, because the GPU have number of thousands of codes, And the deep learning algorithms, there it is a very complex computation in the sense there is a matrix multiplications are there, so which needs suppose there are thousands of the matrix multiplication, and to make the training faster we need to do those computations or calculations in parallel. So GPU will help in executing those matrix multiplication in parallel by providing the codes. So in this way GPU is very helpful. So here the DeepSense, it provides a very good platform for running these applications or models very fast for providing the GPUs. So if we run our here you have to decide what you have in your laptop. So if you have a CPU in your laptop, so accordingly you can decide the algorithms. If you have option of the GPU, accordingly you can decide the algorithms. Suppose if you are working on the real-time application, so in the real time, so if I take an example of the real-time application, like suppose these self-driving cars. So the self-driving cars, what we need is we need the higher accuracy with the training speed very high and the prediction time low. So we need a very good platform for that, for a computing platform. So if in the case of the self-driving cars, if there is a suppose a traffic light in front of that, if it not if the self-driving car doesn't recognize that traffic light in that particular moment, it will lead to an accident. So that's why for the real-time application we need a very high computing platform we need. But if you are not working on a real-time applications, you can use the CPU models also. But if you have an option for the GPU in your laptop, you can select the algorithm accordingly. But if you are working with the DeepSense, the DeepSense will provide a platform for speeding up your projects. So again, this is a picture or image for the difference between the machine learning and deep learning models. So it is very clear from this. In the machine learning model, you need to extract the features and then classification is done on those features and it will give the output. But in the deep learning, the feature extraction and classification, it will be done by the deep learning algorithms automatically. Again, the performance of the deep learning algorithms are very high as compared to the machine learning algorithms. So here I'm going to discuss some of the applications on which the companies are now working. So normally the companies nowadays are using the time series data, they are using the image data, they are working on the NLP problems, like natural language processing problem. So what kind of algorithm they use? So this is from the research paper. I collected some of the data, like if we have the time series data. So there are variety of the time series data. There is a trend data, which is increasing or decreasing trend with time. There is a seasonal data. So there is a repetitive change of the behavior. So if we talk about the machine learning algorithm, so the decision tree and random forest, they are not very much suitable for the time series data. But this SVM can work with the time series data, but because we have a hyper tuning parameter over there, we can change the kernels. We have an option of the kernels, so we can test the kernels for the time series data to check whether it works with the time series data or not. Then naive Bayes and KNN, it may also work with the seasonality and trends. CNN, it may also work with the time series classification such as emotion classifiers. So it can be used for the seasonal time series with trends. RNN with LSTM or GRU, it can work for the future timestamps based upon the previous timestamps. So if you talk about the image classification, again, machine learning classifiers can do the image classification, but it need features. But if we talk about the CNN automatically extract the features from the images and do the classification. So if we talk about the video, now video is the sequence of the images. So we can apply the combination of RNN and CNN for these videos also. Then if we talk about the natural language processing, so in the natural language processing, the machine learning classifiers can also work with these problems for doing the text classification, part of speech tag, document classification, sentence segmentation. CNN can also be used for the sentence classification, sentiment classification, textual summarization. RNN can be used for sequence prediction problems, sequence of data, sequence of speech data, where you have a kind of sequence. At that time the RNN will work. But GPT, these are the pre-trained models again, which is developed by the Google for the NLP problems for the prediction of the next token. So mainly these BERT and GPT, these are using for the prediction of the next token based upon the previous data. So these are some of the examples. So at the end, I must say that these are the algorithm which I suggest that which you can try. But I'm not saying that you should always following the same strategy. Based upon your data, decide what you want. Your data, it is so first of all, you need to decide, or you need to find whether your problem is classification or regression problem. Classify the algorithm. So divide the algorithms into two parts, the classification or the regression. Then see the classification. If it's a classification problem, then see the classification algorithm. Then check whether your data, it is very large or small, it is having the high dimensions or not. Training speed, what kind of training speed of that algorithm, what kind of accuracy of that algorithm. Then see if your data is very large, it is very complex, then you can go for the deep learning algorithms also. If your application is a real-time application, I must say you should go for the deep learning algorithms. And for the computation of deep learning algorithms, if you have an option for the GPUs, so you should go for that, because it will speed up your processing, it will speed up your model. And hypertuning parameters at the end, which is also one of the option for improving the accuracy. So you can improve the accuracy by tuning the parameters. The accuracy can be improved by other methods also, that is called the optimization. But here we are talking about the algorithm. So for making the base model, we should first concentrate on the best algorithm for making the base model. So which algorithm is best? So after deciding, once you have a good model in your hand or good algorithm in your hand, after that you can do a optimization or techniques to more improve that model, to getting a more accuracy. But first of all, try to get a best model in your best algorithm in your hand. So, thank you.
So we have loads of questions, super excited. So you might want to leave the slides up because you might want to slide back to some of them. I'm going to jump around to a couple of them, but if you want to go almost close to the beginning of your questions, there's a few questions in here around what constitutes a small data set versus a large one.
Okay, this is a very interesting question, and it is also very confusing sometimes. What is small data set and what is the large data set? See, if you have, suppose, a very simple trick, if you feel that your data set accommodate in your Excel file, you can consider it a small data set. And large data set, if the data set, it is you extracting the files from the different sources, that is the large data, you can consider it as a large data set if it is unstructured. Or I'm giving another example. Suppose if you're talking about the weather, a small data set is suppose a 6-month data, it will not give you a good result, but a large data like for a 5 or 6 year data will give you a good prediction. So in that way, you can see which one is the small data set and which one is the large data set.
And I think sometimes too, some people get confused about data set size, like a small data set is how many rows and columns versus images. I think there's also, to your point of having days and years and types of information is really critical too. But I think if you're getting into images and video, you want to have lots, like hundreds and thousands.
Exactly.
Okay, there's another one about, we're going to get into scaling and feature extraction in a second, but I'm just double checking. I thought there was another question in here about data size. i.e. rough size in gigabyte or number of rows in which SVM or KNN is not suitable. So is there a suitable size for an SVM, number of rows, gigabytes?
So there is not a particular term for the suitable size, but the thing is, if you feel that the data set it fits on your laptop, or if you can easily work with your laptop with those algorithm, you can consider it as a small data set. Like if you feel that you can open it in a notepad or in Excel sheets, then you can consider it as a small data set. Because with a very large data set, you can't easily work with the models. So you need a cloud for that.
Excellent. And we're going to get into GPUs in a minute. But first, there's a couple other questions. I'll read two of them. Can you please explain a little about feature scaling? And then the second question is, does feature scaling also mean feature extraction?
Feature scaling, it means when we normalize the data. For example, like suppose if you have a data, the various features, and if I talk about, suppose feature scaling means to put a data in a particular range. We normalize the data, like we put the data from 0 to 1. So it will give us the good accuracy, or the models will work better in that form. And the feature extraction is a different thing. We are extracting the important features from the data, which will be helpful for our model, for the prediction or for the output of the model.
Okay, we're going to go down a different path. We have a couple ways to navigate. So one question, do you source your algorithms from our project.org, or do you adapt your own?
I'm not getting your question. Okay.
I think it's like if you're going to pull a script from somewhere in the code. Okay. And
okay, so it depends upon the project which you are writing. So like when you are doing your project for the machine learning, you can directly write your own code. Let's take an example of the TensorFlow. In the TensorFlow, you can build your, like suppose the entire network, but if you are using the Keras is the higher level API, you can directly use the function. So it depends what kind of problem it is, where you need, like suppose if you need the tuning the parameters, if you need the hyper parameter tuning, at that time you can build the entire model with the help of the TensorFlow. But if the project is small, you can directly use the functions for doing the project.
Excellent. Okay, and when you talk, there's another question that I didn't realize, or it came in afterwards. When you talk about small, large data sets or fast, slow training, what do you mean? And I think that's a good one to get into about fast and slow. And this is where I'll lead into another question afterwards about GPU. But someone says, what is small, large in terms of gigabytes and terabytes? And what is fast, slow, days, hours, and weeks? And I think that's a really good question. Are you using your laptop? Are you using GPU? Yeah.
Yeah, this is a very interesting question. So that's why, first of all, I would like to tell you about the pre-trained algorithms. So these pre-trained algorithms, which are already trained with the data set, and it took around some algorithms with 16 days or 17 days to train those models. So once you have the pre-trained models, it will save the time. And if you use those algorithms, it will definitely save the time. And for the training low or training speed large means this, like if your data set is small, and if you are using these machine learning algorithms, sometimes it will take few minutes, depend upon the data. Sometimes it take 1 hour, sometimes it take 2 hours, depend upon the data, depend upon the complexity of the data. And if you have the image data, it will take more time. If you have the image data, and if you have the deep learning algorithms also, it take more training time, maybe in number of days also. So if you have source in the simple terms, if you have a text data, the training time will be less because the data is simple. But if you have the image data or the videos, or in the terms of this audio, so it will take more time because the data is complex, the calculations are complex. If you work on the deep learning models, that there is a large computations, so it will take more time, maybe number of days. So it depends upon the data, what type of data you have. So accordingly, it will take the time.
And I think that's what we see at DeepSense, because we tend to work on all sorts of different types of data with different models and deep learning models versus the machine learning models. And I think one of the things to flag is we know that we've had students who've worked on natural language processing models, which in theory are text, so it should be maybe not as complex. We know that models have taken them a few days to try to run on their own CPU or their own laptops, but then they've come onto our equipment, it takes them maybe an hour or something. So one of the things that we are trying to look at is doing a bit of research to make comparisons to see how much longer and how much faster it can be if they use our equipment. But of course, the flag there is it really depends on what they're currently doing with their own laptop themselves.
Exactly.
And then it comes down to, do you want your laptop? And if something happens and you have you run out of battery, someone unplugs your laptop and it goes dead and you lose your job. So there's a lot of variables in there when it comes down to speed and training. But
and also it depends upon the problem which you are going to solve. Like for example, if it is a real-time application, then you should concentrate about the this training speed. It should be low. Like I already discussed with you an example of the self-driving cars. If the speed is, if it take like last time, then it is, you need to worry about that. So you need something, some kind of that hardware or that kind of infrastructure which would like speed up your projects. So you can do that. Like if it is taking like 1 to 2 days to train the model, so you should shift from CPU to the GPU for speeding up your model.
someone put a question, and I'm not 100% sure I'm getting it, but I'll just try. But they asked about an Intel GPU, so UHD or Iris, and if it can be considered. And I think, I don't know if we probably don't want to go down the road of what GPUs might be better than others, but I think you feel free to answer this one. But in terms of a high level, I assume anything that is a GPU is probably going to be faster than a CPU, and you take what you can get sometimes.
Yeah, if your GPU is, because the TensorFlow or the PyTorch, these can work on the GPUs, and I think these are compatible with the CUDA, CUDNN. If your GPU is compatible with that, then I think it is good to work with that GPU, because all the TensorFlows, so these are compatible with the CUDA, CUDNN. So I think if it is compatible with that, you should go with that.
So here's an interesting one. What is the importance of understanding the algorithm, mathematically speaking, before you apply it? Is that important? Or if I understand only general aspects of, is that enough to use that algorithm?
No, I think mathematically, it is important to understand those algorithms. You should understand how the algorithms are working. Like, what is the concept behind that? Because in all the algorithm, there is a maths behind those algorithm. Like if we talk about the SVM, so I think it should be clear to you how the SVM work, how they classify. Like in the SVM, it works on the hyperplane. The KNN, it works on the neighbors. So the concept of each and algorithm is different. So I think it is important to understand how the algorithm, what kind of math behind that.
Okay, great. So we have a lot of questions, and there's some are very, very specific. So I'm going to go to the high level general ones first, because they might have greater application, and then I'll dig into the more general ones. But how important is learning mathematics for using a deep learning algorithm? I think you kind of touched on it there.
Yeah, in the deep learning algorithm is basically the main two kind of algorithms which we use, like the RNN and CNN, which is totally based upon, a mathematical, the matrix multiplication, and there are the layers. I think for that, you should understand what is the neural network, how it works, what are the various, what is the meaning of the input and output layer, what is the meaning of the hidden layer. So, so there are the hyperparameters like activation function, how activation. So there is a math in the activation function, because the activation functions, it is based upon the sigmoid functions, and there is a tanh function. So you should understand how these activation works. So because in the when you are going to implement the neural network, the activation function plays a very important role. So I think these understanding should be clear to you. So how the activation function, why these kind of loss functions are there, how we can measure the accuracy. So these kind of things you should know before the implementation of the new deep learning algorithms.
And I think it makes sense, because if you were doing this for academic purposes, you're going to probably have to explain it a little. And then if you were doing it for an employment reason, because that's what you were doing. You'd have to be able to explain it to someone too. So I think that's definitely important. But there are two questions here that kind of blend together. And one is, how do you know if the data for the training and testing is enough to build a good model? Does it depend on the problem?
The training and testing data, when you get a very good accuracy, and at that time you can say it is enough. Like when you train the model and it is giving a very good accuracy for in the testing phase, then it means you can say at that time the data is enough. But if it is not, like sometimes there is overfitting problem when you train the model, it will not giving an error, and but the accuracy for the testing model is less, that is overfitting problem. So at that time you can say we need more data to train, so that it can cover the data which you reserve for the testing also. So at that time we need more data for the training, so that it can perform better for the testing also.
And another general question too, how can you be sure if the algorithm is the right one? Through testing, or sorry, through accuracy tests?
Can you tell me which question?
How can you be sure if the algorithm is the right one?
Yeah. So initially, at the initial step, as I already discussed, you should first see the data set, what kind of data set you have. So accordingly, you can apply 2-3 algorithms on it. Maybe it will not give the good accuracy. You can try the another algorithm. Yes, but this is the best way. The various metrics like the accuracy, then there is the precision, recall. So these are the various metrics by which you can say that the algorithm which you chose is the right one.
Great. And sorry, there are some very specific questions, so I'm going to go back again and answer some of the other ones. One is a question about the first time you're hearing about DeepSense. This is great. I'm really glad that you're here. So thank you for joining, and share the story about us with your friends and all your network. DeepSense only works in the ocean sector. So we support ocean sector companies. It's anywhere within the ocean supply chain. It can be aquaculture, military defense, transportation, tourism, environmental, all sorts of different areas. And our computing infrastructure is for students and companies. So we don't provide the infrastructure for students to just use for their own projects and things like that. Unfortunately, there is AceNet in Atlantic Canada or Compute Canada that has that availability that you might have to work through a researcher, but our infrastructure is purely for applied academic research projects. Okay, so gonna then move on to the next one in terms of NLP. Okay, there's a couple NLP questions and transformers. So talking about the transformer question, it's corrected down here. How BERT for NLP extraction and classification can handle time series data as LSTM does.
So BERT, it is basically the NLP model. I know that it is a bidirectional model. It is basically used for predicting the next token based upon the previous as well as the next data based upon the surrounding tokens. So I just know about only this about the BERT model. So it can handle the time series if it is a sequence of the data. So it can predict the next, like if you have a sequence of words for a particular sentence, it can predict the next word in that particular sentence. So the BERT will work in this way. But
all right, and we have 3 more very specific questions, and I don't know if you can see them yourself on screen, but someone is talking about using multinomial naive Bayes, SVM, and neural nets with softmax layer for a project. And they're saying, do you have any advice? We're using it for new classifications. SVM gives higher precision, recall, and F1 score than neural net. Little confused. We are having a group presentation soon. They're looking for some help.
Yeah, sometime it happens. The machine learning models giving the good accuracy than the neural network. As I already discussed in the slides, that when you are talking about the neural networks, it needs a very large data set to getting the good accuracy or good performance. Maybe your data set is small, so that's why it is the SVM is giving the good accuracy. So I think this is the point. So I don't think you need to be confused about that, because it can happen. The other models can work better. It is not always necessary that the neural network will give the good accuracy every time. So it all depends upon the data. If data is small, the other models, the machine learning models can also give the good accuracy.
Excellent. Okay, sorry, and there was a question about in the chat that I was just answering, talking about finding opportunities for DeepSense. So I think, you know, just watch our LinkedIn and our Twitter and our website and Instagram for information. And when we have opportunities that come up, obviously they have to be with the company. So when we do have that come up, sometimes we already know people that will quickly jump into that project, and other times we're out looking for students who can do it. So we post and share those things or engage with our network. I haven't been as great about getting a newsletter out there, so I will work on that one to keep you engaged. Okay, there are 2 more questions here. Oh, 3 more. Okay. How does TF-IDF work? Can you please explain the difference between count vectorizer and TF-IDF transformer?
TF-IDF is basically a term frequency. IDF is inverse document frequency. So basically it is for finding the, mainly this TF-IDF is used for finding which a most important term or a most important word in that particular document. So based upon the value, we can say that this is the word occurs how many times in a particular document. And on the basis of that TF-DF, we can say that the particular document is related to which topic. So it is basically related to that. And second one is the count vectorizer. So the count vectorizer, it is basically, it is not, I think, similar to TF-DIF, because TF-DIF, it is the term frequency of, it is basically to find the frequency of the particular word. And I'm not sure about the count vectorizer very much. What exactly is that?
Oh, good. There's a lot of stuff that we're throwing at you and you were handling it like a champ. Okay, a couple really other quick questions because we're almost out of time. What is the best skill set for getting the most out of deep learning? And then there's a question about whether C++ is important for machine learning and deep learning.
Okay, yeah, C++, if you know C++, it is also very good to know. But in today's scenario, if we see, if you want to work in the industry, if we see from that point of view, they are mainly work on the Python. Python, because the community is strong for the Python, and the deployment is very easy. So the companies feel that the Python is good for the deployment purposes, and there are a lot of functions available there for the deployment. And their main concern is the deployment after making the software, after making the model. So they mainly use the Python. Yes, it is good to use C++ for your own understanding, but if you want to go for some industry, so I think you should also go for the Python also.
Great. And what this best skills for deep learning?
For deep learning, as I already discussed, that the Python, you should know Python, and then machine learning, what exactly, some little bit course about the machine learning to understand the maths behind the various algorithms. And once, before directly going to the deep learning, I think you should understand what exactly is the machine learning, how the machine learning algorithms or the classifier works. And after knowing the machine learning classifiers, you can go to the deep learning, because the deep learning, it is a part of machine learning. First understand what is machine learning, then move to the deep learning. So Python, machine learning, then one is the framework. If you want to go for the suppose for the deep learning frameworks, you can start with the Keras, because Keras provide the higher level API, and it is easy to implement the deep learning deep learning models with the help of the Keras. And yes,
I think one other thing too that often gets missed is understanding elements around the soft skills. So depending on where you're going with this data background on your skill set, really knowing how to apply the deep learning that you're doing is really critical. So if you're working in industry, there's a lot more than just taking data that's been provided. It's of course having an ethical understanding of where the data has been collected, if it's sufficiently robust for whatever model you're trying to build. So I think some of the other skills are soft skills too. Communication and engagement with others are really critical and can sometimes be overlooked. Okay, there's one final question, but I think here's the challenge. it's very specific, but I think it's the last part of it that's really important. And I think I see comments in there asking for us to review it. But here's can you see that question? I think we should focus on the bottom of it first. Can you give us suggestions to improve accuracy? So I think before you get at what kind of model someone's trying to train and what algorithm they're using, how do you improve accuracy? So there might be better to start there and then go back to the top of the question, because they're using regression and others.
So in order to improve the accuracy, in my slides, I discussed that you can do the hyperparameter tuning. You can change the parameters and see what accuracy it is giving. So prepare the base model. And after that, you can do the optimization in which you can augment the data augmentation. So there are various methods of doing the data augmentation. You can apply that for improving the accuracy. So this is my suggestions for that.
And in terms of their feature extraction approach, any suggestions there?
Yes. In terms of the feature extraction, you can check for the features. You can see the correlation between the features. There are two kind of correlation. One is the correlation with the target value. If your features are strongly correlated with the target values, then you cannot eliminate. But if in the training data set, if some features are correlated, you can apply the PCA or the feature reduction techniques on that. And also, if there are, for improving the accuracy, you can check the outliers. So we have a box plot for checking the outliers. So if there are outliers, you can remove those outliers also for getting the better accuracy. Because if there are outliers, the model will behave accordingly. Like the tree structure, it will not very much affected by the outliers. But if you have the another models, like suppose a SVM or naive Bayes, KNN, it will be affected by these outliers. So see if you have any outliers in your model, you can remove those, and the other data augmentation techniques you can apply for improving the accuracy.
And so I'm sure, just to make sure we get full coverage, I don't even know the right way to pronounce this in terms of the latent Dirichlet, I don't know how to pronounce that, allocation.
Latent Dirichlet allocation.
Dirichlet, that's it. Right. And so is there anything that you want to add in terms of this being as an example of a topic model? Is there anything that we should touch on so that those listening understand what that would be and how it could have been misused or should properly be used?
If I'm talking at the end, I must say that for starting this, for doing the project, when you are starting your project, you should first consider the data. Your data is very important for doing the project. So first of all, see what kind of data you have. Like if you are collecting the data from the various sources, then see what kind of then see if the data is in the proper format or not. Like if you have a date in one file, so the same format should be in the another file. So if the data is different, you will not get a very good result. So you should first understand the data, what you want from that data. First try to understand that accordingly, and after that you can work with the algorithms and you can see which algorithm you want to use. So don't overestimate or underestimate the data. First try the data, because data is the very important part. If you have no idea about the data and if you are not very much particular or cleaning the data, then you will not get a very good result. And also, before starting the project, first pre-process your data according to your problem, what you want from that data. Clean the data, pre-process the data. If you need a feature scaling in that, you do that. Whatever you want to clean the data, do those things. And after that, only you will get the good results. And I think once you have the good data set, you can apply the same data set for all the machine learning algorithms, but not for the deep learning algorithms. So in the case of the deep learning algorithms, you cannot try each and every model. Like if you have the pre-trained model 7 or 8, it is not very easy to try each and every model as that of the machine learning. So first explore the model. Like suppose if you have any kind of problem like image classification, explore the models, what those models are doing. Accordingly prepare the data set according to the model and then apply the model. Don't directly go for 3 or 4 models in the case of the deep learning.
Excellent. Well, thank you very, very much. I really appreciate everyone who joined, and we welcome you to reach out to us via our LinkedIn, via our email address that's available on our website. We have Twitter and other types of social media like Instagram. So please be sure to join us for any of our future discussions as well. If you have any suggestions of topics you'd like to hear, please also send those through. And I know that there's probably lots of questions out there. But you know, we will continue to answer them. Hopefully in another session, we can have choosing the algorithm 2.0. So thank you so much. That was fantastic. I really appreciate it. And we look forward to seeing you all next time.
Thank
Bye.
you. Bye. Thank you.
I can't stop recording. Can you stop recording?
Okay.
Great. And then all you have to do on the very end is end the meeting
Recording.
in the corner,
Okay.
and we're good to go. Awesome.
Okay.
Thanks. See you.